All right, so today we're going to be covering 10.7 and 10.8, working with the area of triangles and trapezoids. So working first and foremost, we're going to work with triangles here. So our main equation that we have for determining the area of a triangle, this is regardless of whether it's a right triangle, obtuse triangle, scalene triangle, whatever type of triangle that we have, is always going to be using this formula. The area is equal to 1/2 the base times the height. Some people like writing this in as 0.5 base times height. You can do that also. I like fractions over decimals, but that's just me. But this is our core equation that we're using. If you're ever told find the area of a triangle, this is your go-to. Always and forever. The B is going to represent the base, the bottom of the triangle, and H represents the height, the length of a triangle from the base to the vertex. And this is a very subtle point that a lot of people, more often than not, will just glance over as, I just need the base and I need some kind of another length. So people just look for two lengths and that, oops, sorry, something on the screen here. There we go. People just look for two arbitrary random lengths and just plug them in accordingly. And we do need to be pretty specific about assigning these things their respective values. So just because you have a number that's been given to you, make sure you correctly identify that it is indeed a base or a height. And again, our height has that very specific part that goes along with it. The length of the triangle from the base to the vertex. That being said, the really nice part about working with right triangles, like the one that we have down here, I failed to put the box in there, but it should be there. We can determine a base and we can determine a height just by looking at it. So right triangles are really, really nice in that regard. Others can be a bit trickier, as we'll see with our example that we have here. This doesn't look like a right triangle. This would be a scalene triangle, and we would need to find the area of this thing. So we're going to go through both of these examples, but I just want to give you guys that quick gauge on the types of things that, types of triangles, I guess I should say, that we could be looking at. So I'll jump us over to our whiteboard, but these are the two examples that we're going to go through and how we determine the area for each of them. Jump over there. So first example with this, we were given a right triangle. Oops, that's not particularly good. There we go. Technology making me look better at drawing than I actually am. Okay, so we're determining the area of this triangle, and this is the information we've been given. Now, my recommendation to you guys, I think I gave it to you, I know I've sent it out, that geometry info PDF page that I gave you guys. That is one of the most valuable resources you're going to be using in this section, because when we are working with these things, these geometry problems, we need to know what equation we are working with based on what the problem is asking. So we're being asked to determine the area of the given triangles. Well, I'm working with area, I'm working with triangles. I always recommend doing this, writing out the general equation of what you're going to be working with. I'm working with the area of a triangle. The equation for the area of a triangle, 1/2 base times height. Just write that out for yourself. There's your equation. Now you can fill in what you know and what you don't know and solve for that accordingly. So based on what we have been given, we need to determine the base and the height. So looking at our picture, and again, I think this is one thing I love about geometry, is it lends itself to having visuals in here. The base of this triangle is going to be our 14 feet, it's the part that's on the bottom. And then the height is going to be this distance that we have here, the 6 feet. And all we're going to be doing is just plugging those in, or substituting those in, I should say, for their respective parts in the equation. oops, the base is 14, not 16. There we go. So now that I have everything plugged in correctly, now I'm just doing some calculations. So 1/2 times 14, that's going to give me 7. 7 times 6 is going to give me 42. So the area of this triangle is 42 square feet. Okay. Again, I don't think the math that we're doing this is particularly challenging compared to the other stuff that we've done throughout the quarter. But a lot of this does go into, as long as you have the correct equation, the correct setup for yourself, essentially, you'll be doing just fine with these problems. So we'll take a look at our second triangle. And let's see if it's going to help me out with this one at all. Kind of. My goodness, I can't even draw this thing. There we go. And then we're given that this distance here is 3. And this distance here is 22. Okay. So after finally drawing a decent looking triangle now on my end, again, we're doing the same thing. We're looking for the area of this triangle. So I would always recommend get that general equation written out for yourself. I'm working with the area of a triangle. There's my equation. And now again, we need to identify what is the base and what is the height. So in this instance, we don't have a right angle that's explicitly showing up. We do not have a right triangle in here. So identifying the base, it's going to be this 22 that's on the side. And the height is going to be this distance. I'm going to do it here in gold, or I think this is yellow. I'll call it gold. The height is going to be dictated by this. I'm going to put that dotted there. I'll do it in red, have it stand out a bit better. There we go. The height is that distance that we have there. There are ways that we could go about calculating and determining that height for ourselves if it has not been given to us, but that's going to be for a later class and not something that I'm going to be testing you guys on. So in our instance that we have here, starting with our area, 1/2, our base is going to be that 22, and the height is going to be 3. And again, the height, as it was described in our definition of it, it's the distance from the base to the vertex. Do this in red. So the distance from the base to the vertex, that little point that we have right there. So once we've plugged all of those in, now we're just number crunching. Apply your calculator if you need to. 1/2 of 22 is going to be 11. That's 3. So that's going to give me 33 square meters is the area of this triangle. And those are our 2 examples that we have. Again, there's not really a whole lot to it beyond that in the sense of extra calculations that we need to do. So if you have that part nailed down of having that visual, determining your base and your height accordingly, then that's about everything in terms of actual raw calculations. So I'll jump us back to our notes because I do want to go through an example that does have us working with a bit more steps, a bit more parts to this as well. So again, just this warning again to everyone, if you're computing the height, make sure it creates a right angle with the base, or errors can and will occur with this. So just be mindful of what you're identifying the height to be. Don't just arbitrarily choose, well, that's a number, and I'm going to write that in there. Just make sure you're being methodical about it. But something like this or either of these would probably be something I could give you on the test. Now, taking a look at, I wanted to go through this example because of I think there's some problems on the homework, and I generally try and do a problem or two that's like this on the test also. We're asked to determine the area of a home plate in baseball with the given dimensions. Dimensions listed as 17 inches, run the entire dimensions, not just halfway. Meaning that 17 inches is this entire distance here, and this entire distance that we have here. Yeah? So we're told to find the area and then round our answer to the nearest hundredth. So this is the picture that we're going to be referencing. I'm going to attempt to go draw that over in the whiteboard, and we're going to go through and determine the area of this thing because it wants the area of all of it. So jumping over there. Goes down over here. And let's see if my drawing skills are going to improve for this thing. Almost had it. See if I give it one more try here. Okay, it doesn't like that. We'll leave it like this then. So we have that part there. Had something like that. And again, you guys will, you have hopefully rulers and whatnot that can help you get this written out or drawn out for yourself if you need to. Okay, so we have something about like this showing up, and we're told to find or determine the area of the entire home plate we have here. And there are lots of options on what we could do to make that happen. First and foremost, though, we are working with area, so we need to make sure that we have our correct area equations written out or nearby for us to use. So looking at this thing, there is no direct, here's how you determine the area of this shape for this scenario. I do not know of any formula that would do that anyway. So what we're going to have to do is we're going to take this problem and we have to break it down and work through it in parts, similar to what we've been doing through, I think, most of these sections and just throughout this class. So break it down into parts, solve them individually, and then bring it all together. And breaking this thing down into parts, you have a lot of options on what you could do with that. For me, I'm going to break this home plate down into being two shapes, a rectangle and a triangle. And the way I'm doing that, and the way I'm visualizing this in my head is I'm seeing, actually I'll do this in red to divide this a bit better. I'm seeing this upper area we have up here. I can determine the area of that triangle. I have an equation for that. I can determine the area of this rectangle down here. I can determine, and I have an equation for that. So I'm going to solve for and determine the area of the triangle. I'm going to solve for and determine the area of the rectangle, and then bring all of those together at the very end so we can find the total area here. Now the question that might come up is saying, okay, well, let's work with the triangle first. And the question that hopefully some of you may be thinking of or asking yourself of, okay, well, I've got the equation that tells us it's 1/2 base times height. Great, that's good, fine, and dandy and all. What is the height of this triangle? Meaning, what's the height that we have right here? And if you're asking that question, that's the right one to be asking. So we have been told that the entire distance running along here is 17 inches. We also know that this portion of that is 8.5 inches. So if I know the entire thing is 17, and I know part of it is 8.5, I can determine what's left over by doing 17 minus 8.5. And that should give us, making sure I'm not doing the mental math incorrectly because decimals are showing up. That's going to tell us that the height of that triangle is also going to be 8.5. So again, I'm looking just at the triangle for now, determining the area. So the base of that triangle, it's this distance that's going all the way across here. This particular side has not been given to me for a length, but down here I've been told that this exact same equivalent length is 17. So if this one is 17 and this is equivalent to that, then that makes this distance also 17. So my base for the triangle, 17. The height of the triangle is 8.5. And now I can go through and do some computations with this and determine it on my own. So 1/2 times 17, that's going to be 8.5. And then 8.5 times 8.5. I'm doing that off screen with a calculator. I hope I hit multiply, not added. There we go. So the area of the triangle portion of this shape is going to be 72.25 square inches. Okay? So we're not done, but we have a part of our final answer. So we've determined the area of the triangle portion, this thing, and now we're going to solve for the rectangle portion of this thing. So work with the triangle, working with the rectangle. Our equation for the area, the rectangle, length times width. So all I need to determine is what is the length of this triangle, what is the width of this triangle, plug those in and solve. So looking back at the picture, I have a length of 17 inches and a width of 8.5 inches. So I'm plugging each of these in and I'm solving for the final answer there. So the area length, we'll put that in blue, stay consistent. We'll get to that there. So I have each of those plugged in. I'm now just number crunching. And again, you are more than welcome to use your calculator for that. That's what I'm doing off screen. And I'm getting 144.5 square inches for the area of the rectangle. But again, we are not asked for what's the area of the triangle that's in this? What's the area of the rectangle? We're being asked, what is the total area inside this thing? So now the last thing I have to do, because I've solved for the area of each of its parts, I'm going to just add all of those parts together and then we'll get the total area. So I'm just going off to the side here. So we have the, and if we need to write this out for ourselves, that's fine. Just making sure we know what we're doing. So the area of the triangle was 72.25 plus the area of the rectangle was 144.5. Add those together, and again, apply your calculator with that. That's what I'm doing. And I am getting the result of 216.75 square inches. So as you're going through and working with some of these problems, we're going to find more and more, not just in this section, but you're going to find it in a lot of future classes as well when geometry shows up. We do not have equations to solve for every single possible shape that has been given to us. We can and will need to break it down and solve for this part of it, then for this part of it. Maybe there might be a semicircle over here. Maybe we need to solve for that. But again, the big picture with a lot of these, if If you have something that you don't have a single formula for, break it down and solve it in parts, and then bring it all together at the very end. Okay. So this is everything for the 10.7 material, working with the area of a triangle. So again, just make sure you've got that formula written down somewhere for you, or you have that geometry info page that I gave to you guys, that PDF. Either of those works just fine. But have those equations ready for you. Let's jump back over to our notes and we'll take a look at the 10.8 material. So 10.8 has us working with solving for the area of trapezoids. So our base definition that we have is equation in all of trapezoids. A trapezoid has two parallel sides defined as the bases and the length between them defined as its height. We have that visual over here. We've got a generic trapezoid. We have here is a base, here is a base, and the height is this distance that runs right between them. So we also have then our general equation for the area of a trapezoid. So our equation for that is going to be 1/2 times the quantity of base 1 plus base 2, and all of that multiplied by the height. So these are ones where, with trapezoids specifically, there's not really a particular whole lot I can test you guys on that doesn't just give you 3 of these 4 unknowns. So my recommendation with this, again, I think these become really straightforward when we make visuals of them. Identify the 2 bases, identify the height, and then just plug it into the equation and solve from there. There's not really a whole lot of extra stuff that goes into it beyond that point. Again, I think the big part that trips people up with these is people try and speed through that and just plug in numbers arbitrarily into some part of the equation, or people are not using the correct equation with what they are working with. So again, it's a pretty straightforward process. Identify the missing, or identify what we do know, plug it in for that respective variable, and solve for what's left over. So we're going to go through these 2 examples here. We're just going to jump over to the whiteboard for it, but giving you guys the info on the first ones we're working with. So we'll jump on over to there, and we'll see if I can draw trapezoids. Triangles are already a hassle, so see how this pans out. Okay. So our first one that we're working with so we were given something to the effect of and again, not drawing to scale by any means because not an artist, and oh, it actually did that for me. I'm letting the computer make me look good at drawing over anything else. Okay, so there's our trapezoid that we're working with. We're told to find the area and to round our final answer to the nearest tenths. Okay. So again, I'm finding the area. I'm working with trapezoids. My recommendation to you guys, every time you're going through an area, perimeter, geometry problem, determine the shape and then determine the equation that you are using and write that out for yourself at the very, very beginning. So I'm working with the area of a trapezoid. I'm going to write that out. It's the general equation for that. And now I'm filling in what I know. I've been given 2 bases, base 1 and base 2. As long as we have correctly identified this is our base and this is our base, it does not matter which one you plug in for base 1 or base 2, as long as you know that these are both base values. So I'm plugging each of those things in. Oops, got a better 2 here. And we have also been given the height, against that distance that we have right here. So I can plug 3.5 in for the height. And now I can evaluate and simplify this thing using PEMDAS. So again, big portion of it, this is the new part, or the new material as it were. Identifying the bases and heights, plugging those things in correctly, and then now we can just apply a calculator, apply PEMDAS, and we're just simplifying. So working inside the parentheses, I have 10 plus 12, gives me 22. Done with parentheses, I don't have any exponents, multiplication or division. Multiply left to right, I have 1/2 times 22, that's going to give me 11. 11 times 3.5. I don't know what that is off the top of my head. I want to say it's going to probably be like, I don't know, maybe 34, 36, something like that. 38.5. Apply your calculator if you need to. That's perfectly reasonable. We were told to round to the nearest tenths. Well, it's already done for us in that regard, so I don't need to worry about that. We've got our final answer. So the area of our first trapezoid is 38.5 square inches. Take a look at our second trapezoid that we have shown up here. So we've got something kind of a weirder looking one, but work with it all the same. Something about like that. I'm given this side to be 18 feet. Got 5 feet there. So again, we're looking for the area of a trapezoid. So I'd always recommend start with what is that formula? What's that generic formula? Write that down for yourself. And again, on the test or on the homework, if you guys need to look up and write down, or look up and have that set of notes nearby it, or remember this is what the equations are, the formulas are for it, go for it. That's perfectly fine. That geometry info page, which has all of these on there, is exactly why I gave it to you guys. So now we know what we're working with. We have our equation. We identify any unknowns that we can plug in. So our two bases, 18 feet and 12 feet. So we can plug those in. Stay consistent, doing blue. So we are arbitrarily choosing 18 feet to be our first base and 12 feet to be our second base. We know both of these are base values, but again, which one you assign as base 1 or base 2 is kind of indifferent, as long as you have correctly identified that they are indeed both base values. And the height, and it's that height, that distance between the two parallel sides, so that's going to be 5 feet. I have everything plugged in, and now I'm just simplifying using PEMDAS. So inside parentheses first, 18 times 12 is going to give me 30. 30 times 1/2 is going to give me 15. And then 15 times 5, that's going to give me 75. And we're working with feet. So my final answer in the area of this particular trapezoid is going to be 75 square feet. So not a whole lot else beyond that in terms of determining the area of a trapezoid. I could give you guys an instance where I have given you the area and left out the one of the bases or one of the heights. I guess it's the only height, but at that point in time, you would just be solving for the remaining variable, the remaining thing that's left over, which is basically a 3.5 problem if you were going to go through and try and solve it. But otherwise, this is the new material. I don't think it's as difficult as stuff that we've done in the past, so hopefully this is making some pretty good sense. And again, can't emphasize enough, make that picture for yourself, write out that equation, makes all of these problems way, way, way easier, I think. So that is everything that's new for today. I'll end the recording here and take any questions that you guys have directly after that.